is they can study tremendous quantities of data and they can discern patterns. I just wrote an article that got published today on the Forbes website about how many of you remember the old Sesame Street game, you know, one of these things is different than the other. What's going on with looking at log files, transaction files, is it's one or more of these things may or may not be different than some of the others, but maybe not different than others. And that difference may or may not be malicious. And so a tremendous, and we're talking, you know, megabytes or gigabytes of log data that hopefully your applications are storing with every transaction. It gets huge. One of the things that you can't do with traditional AI, let's say expert systems, is write all the rules to categorize a data and spot outliers. Outliers often are your leading indicator that something bad is happening or starting to happen or will happen soon. Machine learning is really the perfect tool for that, because not only can it look at all that data in near real time, but it can keep looking and keep discerning more and more patterns. But also what machine learning can be really good at, depending on the algorithm, is making predictions like, this outlier might be a problem. It's kind of like you go to a doctor and says, this little thing in your skin may develop into something bad. It's not bad now, but we need to keep an eye on it. So I'm wondering, can you guys talk about the use of AI for, and not necessarily machine learning, but for looking at reams and reams of data and making predictions? And you did touch on that a little bit, but making predictions about what it sees.
Yes. So in what some of my systems are doing, we're looking for web-based threats. That means we need to go out and sample the web. As it turns out, the web is kind of big. So as we sort of sample the web and pull some of that data in and then attempt to classify it, I sort of feel like what resonated about the point that you were making is that there's the piece where you're automating the classification of something. We can use ML and AI and those tools to do that, and that's very useful. But the other thing that is interesting is that as long as you're sort of doing an evaluation, you can use the ML or AI to help you pick out things that you will then go back into later to make improvements to your classification system. And that, you know, that can't be done by hand when you're dealing with a data set that is as big as the web.
Yeah, so in the malware space, one of the traditional challenges that a security company will face is you'll have a non-AI based solution. So let's say like a rules-based system, and you want to transition into a more AI, ML kind of model. Now, when you talk about this, large data set, and you're talking about a transition to a different model, using machine learning can help you really identify the features that you can go after as the low-hanging fruit. So these are like machine learning identified and ranked, items that you can go after, create your rules for, knock off all of the low-hanging fruit in your transition to an AI model. So that's one way to apply machine learning to a very large data set to derive intelligence out of.
So we see the same thing, right? When we think about where we're looking at data, it's what everybody's losing, right? So we focus a lot of our effort on files and databases. And because of that, this happens to be where people tend to lose their data. I've lost all this data. I've lost 3 billion records from this, or I've lost 3 billion records from here, or some number of records. So when we think about the amount of access to those kinds of environments, some banks have upwards to 40, 50,000 databases. So think about just the volume of data in there is one thing. When we think about the amount of access, how many users actually make queries into that data, that's another thing. Then we look at the languages that every database speaks. Every database speaks a completely different language. Oracle and SQL, Sybase, DB2, the data science databases, your big data and things. Everybody speaks a different language. So for us, it's about, yes, being able to take in that large volume of query data, all that data that people are getting, but doing something smart with it. Because what we found is, we think about security professionals, and I don't know all of you, right, but the majority of security professionals do not speak SQL. I can tell you that by go to LinkedIn and type in database security, put in quotes, and you're going to get 30,000 people in the world that claim any database security expertise. So we said we need something that automates this process, that simplifies the process. And so that's where we came about the machine learning piece to say, look, we need, yes, we've got to churn a lot of volume of data. But at the end of the day, we also have to bring our domain expertise into it to say, this query says and means this. Machine learning doesn't provide that to us, but being able to interpret what the query means now feeds into machine learning to allow the machine learning to learn a little bit more. So it's a little bit of a supervised, a little bit of an unsupervised model of machine learning. And the only way I would equate it to would be an auto drive system. So an auto drive system will go out and it's going to say, look, I know to stop at stop signs, and I know to go at green lights. I don't know what to do when there's a cow in the road, so you're going to need to help me and tell me I can take this corner case, and in this scenario, I've got to do something. So I can predict for them that I know a human is not supposed to touch credit cards if they're going to access 80 million credit cards. I can build that policy, and that's probably a standard business policy. But what about a human that touches 2 credit cards every 5 minutes, or every 10 minutes, or every 6 minutes, or however many minutes it happens to be? Those are much more difficult corner cases to try and detect, and those are only corner cases if they're different than all their peers in the environment. And that's what machine learning does for us, is help shrink that amount of, that volume of data and make sense of that volume of data.
I think for us, in the work that we've done, we spend less time thinking about all those interconnections and exposure points, and more about, at least in the large scale case that we've done work on, it's about network topology. It's about what does the network look in its normal state, and can you identify through the use of various forms of artificial intelligence anomalous events on the network that might indicate something bad is happening or about to happen, right? So is the choir, so to speak, warming up for an event? Can you identify those events before that denial of service attack really starts to reverberate across the network? So as it turns out, a lot of the network traffic in high density, begins to look like a waveform. It almost looks like a heartbeat to some degree, right? And so you can begin to look at it in its normal state and start to understand what's anomalous and what isn't, and then dig down further and understand what of those anomalous events are indicative of something bad, and then learn, based on the last time you saw that pattern, something bad happened. Now you've got a model in which you can use potentially to replicate an attack. So we're looking at all the data, all the log files, sort of all the events. So sort of a different approach than the one that Terry's describing.
So let's talk about more of an active defense role. If you're a software developer, you should be doing pen testing, penetration testing, make sure your applications are solid. If you run a network or a data center, or even if you're using cloud platform as a service or infrastructure as a service, you should be doing, that type of penetration testing as well. Perhaps even if you're a larger organization, hiring white hat testers white hat hackers to come in and test your defenses. To walk around and make sure all the windows are closed. And are you guys doing anything with that sort of that type of defense rather than going through log files, using AI as a way to test your defenses?
No. No. So I mean, in our use case, for us to do that, we'd have to build that system, and we're way more focused on building, product-facing systems or customer-facing systems. However, I do think that might be an emerging, set of solutions and services that might come out.
Business opportunity.
Yeah, I've heard some rumors about applying machine learning to things like fuzzing, which seems like there's some smart things that you can do there, and there's less than 30 program analysis experts in the world who are probably looking into some of that. I also think that the idea of using AI or ML to improve simulation technology to do testing, sort of as you're describing, I think that there's something to that there. What I've seen so far are folks who are sort of, it's more a cookbook style than say something that is so dynamic that it would require AI to power it. But yeah, simulation technology is the way of the future.
Yeah, I wouldn't be surprised. So good startup opportunity. Yeah.
So we're kind of half and half, right? So we do leverage our machine learning in a regard that kind of ties to penetration testing, but we use the penetration testing both from a vulnerability perspective to look for vulnerabilities, but more so we see more of a use when we think about classification. So we have a vast amount of data, and I need to know which of that data is important to me and which data isn't important to me, which data is finance data and which data isn't finance data. And then being able to feed that into the machine learning engine so that the machine learning engine has additional context that it can utilize to do the things it needs to do. So if I just feed a query into the system, it doesn't really mean anything, and there's no context that I can take from it. But if I've done a classification or vulnerability test, and I can say there is an element of either my database or my web application, or more importantly, data within my infrastructure that is more important than other data, and I need to apply the clustering, the peer analysis, et cetera, differently to this data than I do other data. And that's exactly what we try to do when we do classification and understand it. I think as we move forward, we'll be looking to do more things when we think about the vulnerability assessments to be able to say, well, how many people are accessing a particular part, let's say, of a web application? How many people are touching a part of a web application that has a known vulnerability? We know our web applications are going to have vulnerabilities without question. So who's accessing those parts of my applications, how frequently, in what ways, in what sources, and what users, et cetera. So from our perspective, it's about feeding the engine, feeding the beast, less so than building in adding it into its own AI model itself, increasing the quality of the data.